Morning all of you. Today we are going to learn about the EFLAG register of 80386 microprocessor. EFLAG register of 80386 microprocessor is a 32-bit register named as EFLAG register. It contains all the flags which control the operation of 80386 microprocessor. It has some flags to provide the status related information about the instruction execution, and it also has the control related flag and system related flag for various operation. The flag control certain operation and indicate the status of 80386. Now, as we know that it is a 32-bit register, but the lower bit of E flag register are named as flags and can be treated as a single unit. This feature is useful when executing 80386 into 8086 or 80286 code, because this part of E-flag register is identical to the flag register of 8086 and 80286. The flag may be considered into the three groups. There are three groups of the different flags which are there inside the E-flag register. One is the status flag, another one is the control flag, and the third one is system flag. If we broadly categorize these kind of flags, then we can say status flag are used basically for arithmetic operations, and the status of instruction execution is reflected by the status flags. Then if we talk about the control flag is basically used in the string related operation. The direction flag is the only flag which is the control flag in E flag register. Then system flag will identifies or reflect the information related to the system related operation, or it also tell us about the privileges, about the interrupt status, and other information related to the system in in 80386 microprocessor. Now this is the representation of the E flag register. Here you can see that the higher 16-bit of the E-flag register are being reserved for the future used, and only the flags part of the 16-bit register will have all those flags which are used for various purpose. Now here you can see these flags are being categorized into three categories. The X will reflect the system flag. The X category will show you the system flag. The S category will show you the status flag, and the one flag which is being denoted as the C is showing you the control flag. Now there are some bits which are being initialized previously: 1, 0 and 0. This is your first, third, fourth and sixth bit of E flag register. Now, if we see, CF represent the carry flag, PF represent the parity flag, F represent the auxiliary flag, ZF represent the zero flag, SF represent the sign flag. All these flags are different status flag which will show you the information related to the status of instruction execution and basically used in arithmetic operation. Now, the next is the TF flag, which is the trap flag, which is another status related flag. Then IF, which is the interrupt flag. It is showing you the information related to the system operation. Then DF is a control flag which is basically used in the string operation. It is called as the direction flag. OF is called as the overflow flag, and it is also a status flag which shows the information related to the instruction execution. Now there is one flag which is of the 2-bit, which is the IOPL, because it shows the privilege level and it is a 2-bit value. 0001, 10 and 11, these are the possible values for the IOPL. Then there is NT, which shows the nested task and it is also a system flag. RF, which will show the resume flag and it is also a system flag, and VM, which will show the virtual 8086 mode. We are going to see in detail what these different flags do. Now, the first one is the status flag. The status flag of E-flag register allows the result of one instruction to influence the later instruction. The arithmetic instruction use OF, SF, which is the overflow, sign flag, zero flag, auxiliary flag, parity flag, carry flag. For example, CMPS instruction, which is called as the compare instruction, or the loop instruction, LOOP or LOOPE instruction, use the zero flag to signal that their operation are complete. There are instructions to set, clear, and complement carry flag before the execution of an arithmetic instruction. Now, the next thing is the control flag. As I told you earlier, the direction flag DF is the control flag, which is the only control flag in EFLAG register. DF of the EFLAG register control the string instruction. The DF stands for direction flag, which is the 10th bit of the EFLAG register, setting the DF cause string instruction to auto increment, and that is to process the string from higher address to the lower address. And clearing the DF flag will cause the string instruction to auto increment or process the instruction from low address to the higher address. Now, the last one category of the E-flag registers are the system flag. These flags are the last one flag in this category is the virtual 8086 mode, which permit the 80386 to behave like a 8086 microprocessor, but it will be a high speed microprocessor. Then there is another flag which is called as the RF flag, or we can call it as the resume flag, which is used by the debug register DR6 and the DR7. It enables you to turn off certain exception and debugging code. Then there is a flag which is the NT flag or the nested task flag. Used to you this flag is used basically in the protected mode, and when it is set, it indicates that one system task has invoked another via call instruction rather than the jump instruction. Then there is a privilege flag. As I told you, that is a 2-bit flag and it has the 4 possible values, and it is used in protected mode to generate 4 level of security. And then there is another flag which is called as the interrupt enable flag. When set, the processor recognizes the external interrupt on the INTR pin. But uh, the interrupts are recognized and acted on as they are received. The bit can be cleared to turn off the interrupt processing temporarily. So in that particular scenario, your maskable interrupts can be disabled if we disable this particular bit. So interrupt enable flag is also a category of the system related flag. Thank you.